Maybe in class it didn't go over well. All you need to know is, let's say you get to the column 13 that you see on your periodic table here. Aluminum, gallium, indium, thallium. Those, according to the inert pair effect, can either have a +1 or +3. The +1 is if you start counting in the P block. The +3 if you start counting in the first column. 1, 2, 3. So the column 13 could have +1 or +3. Column 14 could have +2 or +4. So first one was 1 and 3, then 2 and 4. The next column would be 3 and 5, so they're both adding 1 each time. The next column would be 4 and 6. Okay? So if you take a look at the periodic table, let's see the one that I can point to. And you can write this on your periodic table when you start the test in case you're afraid to lose it from your brain. This would be 1 and 3, 2 and 4, 3 and 5, 4 and 6. So the smaller number would count 1, 2, 3, 4. The larger number would count 3, 4, 5, 6. Okay? It's that simple. Yeah. So why does something like sulfur have so many possible oxidation states? There's several elements that would have numerous oxidation states that are not predicted from the inert pair effect. You don't need to memorize let me flip over to that table once I find it. On page 72, you shouldn't be memorizing this, if that's what you're asking. No, no, no. These are just common ones for fun. This is here for fun. This is what I've just been telling you. 1 and 3, 2 and 4, 3 and 5, 4 and 6. Okay? The plus charges are for metals. If you have a metal, it would have a plus charge. That's an oxidation. If you have a non-metal, you'd expect a minus charge. If you have a semi-metal or metalloid, you'd expect both, because it could go from both directions. So, for example, for tin and lead, they're just straight up metals. You'd expect them to be 2 and 4. But for something like antimony, it's right on the line. So you can see it right here on this. So you'd expect 1, 2, 3, and 1, 2, 3, 4, 5. So 3 and 5. And going from the other direction, minus 1, 2, 3. Just like you would do in 2a, you'd say, oh, this is the -1 column, the -2, the -3, the -4, etc. So you could count both ways if they're on the line. Yes? Well, if you're talking about here, why not? Because this is just the common charge, the most common. So don't memorize this. This is just for fun. Okay. Yeah, if you didn't know what was common, you just say based on the inert pair effect, and it being a semi-metal, what would you pick? Then you would say, well, 2 and 4, and minus 1, 2, 3, 4. Is that okay? So these are just common charges, not to memorize, just for fun. It's here. Okay? This is what really happens, but we're using this to predict. Now, it could have a -4 charge, it's just not the common charge. This is the most common charge. That doesn't mean it's the only charge. So for example, aluminum could be +1. It's the other charge that happens for aluminum. However, it's not the most common. So I only listed +3. You're only applying this. This is you, right here. Is that okay? So if I had aluminum, you wouldn't know better, you would say 1 and 3. Okay? So it's just that simple, just counting. That's it. Okay, that's all you asked me about main group. The very last subject is color. I don't know if I have an example of this one. Does anybody have one? I could look around.